Hello friends, welcome to ACE4 Technologies. I am back with another topic which is data pre-processing. This is a part of the data analytics and machine learning process that data scientists spend most of their time on. Data pre-processing is a data mining technique which is used to transform the raw data in a useful and efficient format. Now, but why should we pre-process the data? Real world data is often incomplete, inconsistent, and or lacking in certain behaviors or trends and is likely to contain many errors. Data pre-processing is a proven method of resolving such issues. So quality data gives you good mining results, and this is one of the mantras of data mining. Data preprocessing is used in database driven applications such as customer relationship management and rule based applications like neural networks. In machine learning processes, data preprocessing is critical to encode the dataset in a form that could be interpreted and passed by the algorithm. This pre-processing involves 5 different tasks like data cleaning, integration, transformation, reduction, and discretization. Today, we are going to discuss more on all these tasks. Now comes the first task, data cleaning. Now, what is data cleaning? Data cleaning is the effort to improve the overall quality of data by removing or correcting inaccurate, incomplete, or irrelevant data from a data system. The goal of data cleaning is to achieve consistent, complete, accurate, and uniform data. Usually, the data will have missing values. It may also have outliers and noisy data, or it may have inconsistent data. So it is very important to remove all this in order to have a quality data. Remember, as I said, what is the mantra of data mining? Quality data. So quality data gives you good mining results. Now let us see what is the missing data. Missing data are problematic because most statistical procedures require a value for each variable. When a data set is incomplete, the data analyst has to decide how to deal with it. Data can be missing for many reasons. For example, suppose when collecting data for research purposes, the researchers sometimes will not be able to collect some observations. Also, sometimes the equipment fails, or there may be situations when the entered data is incorrect or there will be a data entry error. Now, to deal with the missing values, first we need to understand what are the types of missing data. There are 3 types of missing data. The first is MCAR, that is missing completely at random. We mean that the missingness has nothing to do with the observation being studied. Sometimes we may miss data due to loss of a questionnaire, or we will not be able to measure weights as the weighing machine ran out of batteries. So all these are examples of MCAR, missing completely at random. So basically, this can be due to equipment failure or due to faulty machine design or data lost by a post. Missing at random is the next one, which is MAR. When we say data are missing at random, we mean that the missingness is to do with the person but can be predicted from other information about the person. It is not specifically related to the missing information. For example, if a person does not attend an interview because the person was ill, this might be predictable from other data we have about the person's health, but it would not be related to what we would have measured had the person not been ill. Now, what is missing not at random? MNAR. Now, missingness is MNAR when N, the reason for missingness, depends on the missing values themselves. For instance, suppose people don't want to share their income when it is below 1000 rupees per month because they feel that sharing that would lower their dignity. So this is a Classic example of missing not at random. So friends, now we need to think how we can deal with these missing values. What can be done to remove these or handle these? So missing values can be handled in two ways. Either you can omit the values, that is ignore the values, or you can fill the missing values with some possible values. Now what is this ignoring the values? This approach is suitable only when the data set we have is quite large and multiple values are missing within a tuple. Now, if you are trying to fill the missing values, you can choose to fill the missing values manually by attribute mean or the most probable value. Now we have dealt with the missing data. Our next task is how to handle with the noisy data. So this can be handled either by binning, clustering, or by regression. Now what is this binning? This method works on sorted data in order to smooth it. The whole data is divided into segments of equal size and then various methods are performed to complete the task. Each segment is handled separately. One can replace all data in a segment by its mean or boundary values can be used to complete the task. The next is regression. So here data can be made smooth by fitting it to a regression function. The regression used may be linear, having one independent variable, or multiple, having multiple independent variables. The next approach is clustering. This approach groups the similar data in a cluster. The outliers may be undetected or it will fall outside the clusters. Now that we have discussed the data cleaning process, the next task that comes in line in the data pre-processing is data integration. Since data is being collected from multiple sources, data integration has become a vital part of the process. This may lead to redundant and inconsistent data, which could result in poor accuracy and speed of data model. To deal with these issues and maintain the data integrity, approaches such as tuple duplication deduction and data conflict deduction can be done. The most common approaches to integrate data are data consolidation, data propagation, and data virtualization. Now, what is this data consolidation? So here, the data is physically brought together to one data store. This usually involves data warehousing. Data consolidation enables businesses to streamline their data resources, discover patterns, and look for insights in multiple types of data. The next is data propagation. In data propagation, copying data from one location to another using applications is done. It can be synchronous or asynchronous and is event driven. The last one is data virtualization. Here, an interface is used to provide a real-time and unified view of data from multiple sources. The data can be viewed from a single point of access. That is, data virtualization integrates data from disparate sources without copying or moving the data, thus giving users a single virtual layer that spans multiple applications, formats, and physical locations. This means faster, easier access to the data. It enables effective data analytics and is critical for predictive analytic tools. Effective use of machine learning and artificial intelligence is unlikely without data virtualization. The next is data transformation. Data transformation is the process of converting data from one format or structure into another, typically from the format of a source system into the required format of a destination system. It involves four types of tasks like normalization, attribute selection, discretization, and concept hierarchy generation. So what is normalization? Normalization, which is also called data pre-processing, is an important technique for data transformation. Here, the data is transformed so that it falls under a given range. When attributes are on different ranges or scales, data modeling and mining can be difficult. Normalization helps in applying data mining algorithms and extracting data faster. The popular normalization methods are min-max normalization, decimal scaling, and z-score normalization. The next is attribute selection. So in this, new attributes are created from an existing set of attributes. For example, in a data set of employee information, the attributes can be employee name, employee ID, and address. These attributes can be used to construct another data set that contains information about the employees who have joined in the year 2019 only. This method of reconstruction makes mining more efficient and helps in creating new data sets quickly. The third task is discretization. This is a process of converting continuous data into a set of data intervals. Continuous attribute values are substituted by small interval labels. This makes the data easier to study and analyze. If a continuous attribute is handled by a data mining task, then its discrete values can be replaced by constant quality attributes. This improves the efficiency of the task. This method is also called data reduction mechanism, as it transforms a large data set into a set of categorical data. Discretization also uses decision tree based algorithms to produce short, compact, and accurate results when using discrete values. The last one is concept hierarchy generation. So in this, values for nominal data are generalized to higher order concepts. Concept hierarchies can be used to reduce the data by collecting and replacing low-level concepts with higher-level concepts. In multi-dimensional model, data are organized into multiple dimensions, and each dimension contains multiple levels of abstraction defined by concept hierarchies. This organization provides users with the flexibility to view data from different perspectives. Data mining on a reduced data set means fewer input or output operations and is more efficient than mining on a larger data set. Because of these benefits, discretization techniques and concept hierarchies are typically applied before data mining rather than during mining. The next task in data preprocessing is data reduction. Since data mining is a technique that is used to handle huge amount of data, while working with huge volume of data, analysis became harder. So in such cases, we use data reduction technique. It aims to increase the storage efficiency and reduce data storage and analysis cost, which is very important. In data reduction, we have data cube aggregation, attribute subset selection, numerosity reduction, and dimensionality reduction. So in data cube aggregation, aggregation operation is applied to data for the construction of the data cube. In attribute subset selection, the highly relevant attributes should be used, rest all can be discarded. So for performing attribute selection, one can use level of significance and p-value of the attribute. The attribute having p-value greater than significance level can be discarded. In numerosity reduction, this method enables to store the model of data instead of the whole data. For example, regression models. Then comes dimensionality reduction. This reduces the size of data by encoding mechanisms. It can be lossy or lossless. If after reconstruction from compressed data, original data can be retrieved, such reduction are also called lossless reduction, else it is called lossy reduction. The two effective methods of dimensionality reduction are wavelet transforms and principal component analysis, which is shortly called as PCA. The next task in the data preprocessing is data discretization. Data discretization techniques can be used to divide the range of continuous attribute into intervals. Numerous continuous attribute values are replaced by small interval labels. Now we have two types of discretization methods. One is top-down discretization, another is bottom-up discretization. So in top-down discretization, if the process starts by first finding one or a few points called split points or cut points to split the entire attribute range and then repeat this recursively on the resulting intervals, then it is called top-down discretization or splitting. Now in bottom-up discretization, if the process starts by considering all of the continuous values as potential split points, removes some by merging neighborhood values to form intervals, then it is called bottom-up discretization or merging. Discretization can be performed rapidly on an attribute to provide a hierarchical partitioning of the attribute values known as concept hierarchy. So remember, I was explaining you about concept hierarchy while we were discussing about data transformation. For the discretization and concept hierarchy generation of numerical data, there are typical methods which are involved. Those are data discretization by binning. So this is a top-down unsupervised splitting technique based on a specified number of bins. The next is data discretization by histogram analysis. In this technique, a histogram partitions the values of an attribute into disjoint ranges called buckets or bins. It is also an unsupervised method. The next is data discretization by cluster analysis. In this technique, a clustering algorithm can be applied to discretize a numerical attribute by partitioning the value of that attribute into clusters or groups. The fourth one is data discretization by decision tree analysis. So here a decision tree employs a top-down splitting approach. It is again a supervised method. To discretize a numeric attribute, the method selects the value of the attribute that has minimum entropy as a split point and recursively partitions the resulting intervals to arrive at a hierarchical discretization. The last is data discretization by correlation analysis. This employs a bottom-up approach by finding the best neighboring intervals and then merging them to form larger intervals recursively. It is again a supervised method. So friends, hope you had a good understanding on what is data preprocessing. Stay tuned for more updates and videos on this topic. Please don't forget to subscribe to the channel. Stay tuned, stay updated and stay safe. Thank you and see you again.